This question has a fun little diagram, and there's a shark getting close to the beach, and when it gets close, this siren warns the swimmers. It says that the siren varies inversely with the square of the distance. So as soon as you see that, without really going any further, we know that I, the intensity, varies inversely with the square of the difference of the distance. So we can write down the relationship using that proportionality or fish symbol. And it tells us that it's known that a distance of 1.5 meters gives a intensity of 4. So that means that when I is equal to 4, D is equal to 1.5. So we need to show that I equals 9 over D squared. So we can use the relationship that we formed earlier. I is equal to K over D squared, but we know that when I is 4, D is 1.5 squared. And then on your calculator, you can use numeric solve, and we find that K is equal to 9. So we've then shown that first part. Then we need to sketch the curve of I on the axis. So we can go to our calculator for this one. We already know the relationship of the function or the function. We can see that I is the y-axis and D is the x-axis. So it's just essentially y equals 9 over x squared. So we're going to just type that straight into our calculator. So using the fractions, so 9 over x squared. And then we can go to our graph. Now you may have one that looks like mine. It's not very useful, so we need to change the axis into what it was given in the question. So x should go from 0 to 6. Now personally, I don't like to leave mine on 0, so I'm actually going to put -1 because I want to see the axis. And we know that it goes through to 6, and then the y-axis goes from -5 up to 20. So -5 through to 20, and then we can graph, we can see what's actually happening. So obviously we don't need this kind of left-hand part because our axis starts at 0. So we can see it kind of comes down. We've got a curve there, and it doesn't cross at the axis, but we can double check there. So if we look at the table, ours goes up to 6, and yet we can see it's not crossed, it's still at a quarter. So it's tending towards this asymptote. It says in the question that we need to clearly have the point labelled 1.54. So we can go second function and trace, find the value of 1.5. And we can see roughly where that lies. And then just copying that approximately onto your graph and labelling that as 1.54. And that was the point that we found earlier or used earlier to find the value of K. And then the last part of the question says that while swimming, Scarlett can hear the siren only if the sound intensity at her location is greater than 1.5 times 10 to the minus 6. We need to find the values of the distance where they cannot hear the siren. So for this one, we know that the intensity needs to equal 1.5 times 10 to the minus 6. And then we're using our formula to find D. We need to change the 1.5 times 10 to the negative 6 to an actual decimal. So using standard form, that would be this. And that is then equal to 9 over D squared. So we're needing to solve that equation. Now, because we've already got it graphed on our calculator, we might as well use this as our method for solving. So we have 0.000015. And then we're going to find that value. Now, it might be the case when I do this that I want to find my intersection. And it could say to us that there's no intersection found. Yeah. When that happens, it's because the intersection is outside of the range you're looking at. So it's obviously further away than 6 meters. So I'm just going to change this to, for example, let's try 1,000. In fact, let's try 3,000. Let's just go really big. Okay, now we know that somewhere there might be some sort of intersection. So we can, again, do second function trace, intersect. And there we go. So we can see it's at 2,449 meters. So when the distance is 2,449 meters, or, well, let's put that properly. So 0.49, so to 3 significant figures, 2,450 meters, or we can say 2.45 kilometers. So that's how far away she would be swimming and be unable to hear the siren. And then that should be written as an inequality, because it says find the values of where she can't hear the siren. So it's when she's swimming further than 2,450 meters. So when D is more than 2,450.